Probability. In this module, you will learn about the basic terms used in probability. A 2020 cricket match is going to start in the stadium between Team A and Team B. The captains of the team, named X and Y respectively, are standing with the umpire as this game will be started with a coin toss. Can you answer what is the percentage of chance to win the toss? Oh, yes, it would be a 50-50 for both the teams. Can you explain how? A coin has two sides, head and tail. So when we toss a coin, there are only two possible outcomes. The coin either lands with the head side up or it lands with the tail side up. So this was an activity to decide who'll win the toss. Such an activity which ends with a definite outcome is called an experiment. And the outcome of an experiment is called an event. According to the outcomes shown here, we can define two events. First is getting a head and second is getting a tail. Now can you find the probabilities for the given events? As we had already shown above that there are only two outcomes or possibilities, and these are none other than head or tail. So the probability of getting a head is 1/2, and same for getting a tail is 1/2. The numerator of this fraction shows the number of trials in which the event happened, and the denominator shows the total number of all possible outcomes of the experiment. These can also be written in the form of decimal as 0.5. If you notice here, since the probability tells us the likelihood of an event occurring, such events are called equally likely events. As we have seen that on tossing a coin, we get heads or tails, and there are no other options other than these. It also satisfies a condition, that is, probability of event getting head, which is 1/2, plus probability of event getting tail, that is also 1/2. That makes 1. So these events are complementary events. Now, let us look at a dice. If we roll a dice, we may get 1, 2, 3, 4, 5, or 6. So these are the only possible outcomes we get by rolling a dice. Now, if you have been asked about the probability of getting each number, then what would it be? To find the probability of getting each number, we first need to find the total number of outcomes and the number of times the event occur, for which we are finding the probability. Also, as we know, the formula for getting an event is the number of favorable outcomes to that event upon the total number of outcomes. There is only one way of getting a number 1, and the total possible outcomes are 6. Here we can say that the probability of getting a number 1 at one throw of dice is 1/6. As there is only one way of getting each number individually, so the probability of getting a number 2, 3, 4, 5, and 6, it would be same for all the events that are 1/6. What can you say about the above, as all have the same probability? These are all showing equally likely events. Can you write the sample space for throwing a dice? As we know, the possible outcomes by throwing a dice are 1, 2, 3, 4, 5, or 6. These are called sample space, and we name it as S. Thus, we can say that the sample space of an experiment or random trial is the set of all possible outcomes. Is it possible to find the probability of getting a number 7 on throwing a single dice? No, As we know that there are only 6 possible outcomes in a single throw of die, and these are 1, 2, 3, 4, 5, and 6. Since no face of the dice is marked with 7, so there is no outcome favorable to 7. So, number of favorable outcome to 7 is 0, and as we already know, the total number of outcomes is 6. Then, probability of getting a number 7 will be 0. In other words, we can say that the probability of getting a number 7 is an impossible event. Now, is it possible to find the probability of getting a number less than 7 on throwing a single dice? If yes, then find its probability. Since every face of a dice is marked with the number less than 7, so it is possible to find the probability of each and every number. As, if you notice here, the number of favorable outcome is same as the number of possible outcomes, that is 6. Then the probability of getting a number less than 7 is 6 upon 6, that is 1. The probability of an event which is sure to occur is 1. Such an event is called a sure event, or we can say a certain event. Let's recap. A possible result of an experiment is called an outcome. For example, on throwing a dice, the possible outcomes are 1, 2, 3, 4, 5, 6. The sample space of an experiment or random trial is the set of all possible outcomes. For example, on throwing a dice, the outcomes we get are 1, 2, 3, 4, 5, 6, called sample space. The outcome of an experiment is called an event. The probability that tells us the likelihood of an event occurring. Such events are called equally likely events. Complementary events happen when there are only 2 outcomes. For example, on throwing a coin, we either get head or tail. In other words, the complement of an event happening is the exact opposite, that is, the probability of it not happening. The event that has no chance of occurring is called an impossible event. For example, on throwing a dice, it is impossible to get a number 9, so getting a 9 on throwing a dice is called an impossible event. A sure event is an event which always happens. For example, it's a sure event to obtain a number between 1 and 6 when rolling an ordinary dice.